Apply Hess's law to find the overall enthalpy of the reaction. Delta H degrees overall enthalpy is a state function, meaning that the overall enthalpy change of a multi-step reaction is equal to the sum of the enthalpy changes of its individual elementary steps. Step 1. Delta H degrees 1 is equal to 242 kilojoules per mole of reaction. Step 2. Delta H degrees 2 is equal to 4 kilojoules per mole of reaction. Step 3. Delta H degrees 3 is equal to minus 432 kilojoules per mole of reaction. Summing these values yields delta H degrees overall equals 242 kilojoules plus 4 kilojoules plus minus 432 kilojoules equals math 186 kilojoules per mole of reaction. Analyze the stoichiometry of the overall reaction by combining and canceling the intermediates, Cl and H. In the 3 steps, we get the overall balanced chemical equation. H2 plus Cl2 is in equilibrium with 2 HCl. This balanced equation demonstrates that 2 moles of HCl are produced per mole of overall reaction. Scale the enthalpy change per mole of product. The calculated overall enthalpy change of minus 186 kilojoules is associated with the reaction as written, which generates 2 moles of HCl. To find the energy change per single mole of HCl produced, we must divide the overall enthalpy change by 2. Delta H degrees per mole of HCl equals minus 186 kilojoules over 2 moles HCl equals minus 93 kilojoules per mole HCl. This identifies option A as the correct answer. The correct answer is option A, minus 93 kilojoules.